Name the literal and numerical coefficient in the following terms. Number 1. A times B times C. 1 is the numerical coefficient, and A, B, and C are the literal coefficients. Number 2. 5 times A times C plus 4 times A times D. 5 and 4 are the numerical coefficients. A times C and A times D are the literal coefficients. Number 3. 423 times xy squared. 423 is the numerical component. X times y squared are the literal components. Simplify the following. Number 1. 12x plus negative 12x. These two terms are additive inverses and cancel each other out. Thus 12x plus negative 12x is 0. Number 2. 3y minus 2y plus 10y. Since this problem contains only like variables, you can ignore the literal coefficient and act as if you are adding three numbers. 3 plus negative 2 is 1. 1 plus 10 is 11. Reinsert the y and you have 11y. Number 3. 3x plus 10y minus 4x plus 8y. This problem is a little different because it contains two different variables, x and y. You can only add the numbers with like variables. Thus you can add 3x minus 4x to get negative x, and 10y plus 8y to get 18y. Number 4. 1/4 x minus 5/8 x. In order to add these numbers, they must have a common denominator. Since 4 and 8 both evenly divide 8, let 8 be the common denominator. Multiply 1/4 x by 2/2 to get 2/8 x. 2/8 x minus 5/8 x is negative 3/8 x. Number 5. 1/3 x squared plus 2/3 x squared is 3/3 x squared. 3/3 is 1. The solution is x squared. Number 6. 8y minus negative 5x plus 3x. First, change the sign of minus negative 5x to get positive 5x, because an even number of negative signs results in a positive number. Because only 5x and 3x have the same literal coefficient, these are the only terms which can be added. 5x plus 3x is 8x. Therefore, the solution is 8y plus 8x. Number 7. 1/3 times 6x squared. Since 6 divided by 3 is 2, the solution is 2x squared. Number 8. Negative 1/7 times negative 7n. Negative 7 divided by negative 7 is positive 1. The solution is n. Number 9. 12 times y minus 2 plus 6 times 8 minus 4y. First, we must eliminate the parentheses in this problem. Multiplying y minus 2 by 12 yields 12y minus 24. Multiplying 8 minus 4y by 6 yields 48 minus 24y. Next, combine all the like terms, which are 12y and negative 24y. The only remaining components are the constants, negative 24 plus 48, or 48 minus 24. The equation now reads 12y minus 24y plus 48 minus 24, which is negative 12y plus 24. Number 10. Negative 8x plus 5 times x minus 7 times 3 minus 2x. First, you must simplify the innermost items. Items within the parentheses 3 minus 2x cannot be further simplified. Our first real operation will be to multiply negative 7 by 3 minus 2x. which is negative 21 plus 14x. Next, add x minus 21 plus 14x. There are two like terms, x and 14x, which is 15x. Let's add these terms to get 15x minus 21. Now multiply 15x minus 21 by 5, which yields 75x minus 105. Adding the like terms, negative 8x plus 75x yields 67x. The final solution is 67x minus 105. Number 11. 8y minus 3 times y minus 8x plus 2 times 7x minus y. There are no like terms in this first set of parentheses. Thus, multiply y minus 8x by negative 3, which is negative 3y plus 24x. Multiplying 7x minus y by 2 yields 14x minus 2y. In order to further simplify this problem, we must group all the like terms together and perform the indicated operation. First, add the numbers with like signs. Thus, negative 3y plus negative 2y is negative 5y. 8 minus 5y is 3y. 24x plus 14x is 38x. The final solution is 3y plus 38x. Number 1. The sum of 8 and y means add 8 and y, which is 8 plus y. Number 2. 20 less than the square of x. The square of x means multiply x by x, which is x squared. Then subtract 20 from x squared. The solution is x squared minus 20. Number 3. The product of 3 and the total of y in 7. First add y in 7, which is y plus 7. Then multiply the total by 3. The final solution is 3 times y plus 7. Number 4. 15 more than 1/2 the square of x. The square of x is x times x, which is x squared. Multiply x squared by 1/2. Finally, add 15. The final solution should read 1/2 x squared plus 15. Number 5. The difference between the square of x and the total of x and 17. This problem must be solved in stages. The square of x means multiply x by x, which is x squared. Next, determine the total of x and 17. Since the value of x is unknown, we can only add x plus 17. Finally, determine the difference between these two components. The solution is x squared minus x plus 17. Number 6. A number divided by 9. Let y represent the unknown number. Divide the unknown number y by 9. Thus you have y divided by 9. Number 7. The quotient of 5 and the total of 12 and a number. The total of 12 and a number means add 12 and an unknown quantity. Let x represent the unknown quantity. Thus we have 12 plus x. Since we want the quotient of two components, divide 5 by x plus 12. Number 8. A number decreased by the difference between 4 times the number and 5. First, let x represent the unknown number. In order to solve the second half of this problem, the difference between 4 times the number and 5, we must multiply the unknown quantity x by 4, which is 4x. Next, we must subtract 5 from 4x, which is 4x minus 5. Finally, we must subtract the unknown quantity x from 4x minus 5, which yields x minus 4x minus 5. This solution can be further simplified because it contains like terms. First, we must remove the parentheses and alter the signs of the components. Thus, 4x becomes negative 4x, and negative 5 becomes positive 5. Now the problem reads x minus 4x plus 5. X minus 4x is negative 3x. The final solution is negative 3x plus 5. Number 9. The sum of 5 more than the total of the square of a number and twice the square of the number. Let x represent the unknown number. The square of a number is x times x, which is x squared. Twice the square of a number is 2 times x squared. The total x squared plus 2x squared is 3x squared. The sum of 5 more than 3x squared is 3x squared plus 5.